So here we're at the table saw. The table saw is one of the most useful and versatile pieces of equipment we have in the wood lab. You can make rip cuts, cross cuts, angled miter cuts, dado cuts, cuts for joinery. We can do a lot of basic material processing here. The table saw also happens to be one of the most accurate. The table saw can very easily keep less than 3 thousandths of air between cut to cut. In most cases, your error that you're going to have is due to the flatness of your cut. In these examples I have here, this piece of stock was cut very cleanly. If you look at it straight down the edge, it's a very smooth piece of wood. This has around 1/1000th worth of deviation on flatness. So when I cut stock and I have a clean cut like this, I typically have parts within 1 or 2 thousandths of each other as far as the length and width goes. This piece here, as the operator cut it, if I look along, I can see lots of little striations or rough machining marks. So as they were cutting, they had poor cut technique. They were either twisting their wrist or the fence or something wasn't quite set up parallel as it should be. The throat plate can also be off a little bit. So if you have a nice clean cut and you look along your stock, a nice clean edge, you can hold 1/1000th worth of flatness on hardwood. With plywood, it's a little higher, maybe 5 thousandths or so. If you have striations on here like this, you're looking more around 10 thousandths or more worth of air, and that air is all introduced due to operator error while cutting. So as previously mentioned, the table saw used for cross cuts and rip cuts, those terms are confused a lot. Traditionally speaking, a rip cut is along the wood's grain and a cross cut is across the wood's grain, but that gets thrown out with plywood, so we don't really follow those rules then. It also confuses people as to what you're doing and when. Basically, you're going to rip cut with your wider teeth saw blades, and you're going to cross cut with your narrower teeth blades. On the side over here, we have plywood blades and cross cutting blades available. So right now I have a rip cutting blade installed. So rip cutting blades, the teeth are further apart, cross cutting, they're closer together. That just matters if you're going with the grain or against the grain. People kind of conflate this with how they should hold and support the part. The most important thing you can do is you always support the longest side on the table saw. No matter what you're doing, when you look at your stock, the longer side is what you're going to be supporting. So if I'm making a rip cut, I'll put the long side against the fence and I'll rip the material across. If I want to make a cross cut, I can pull back the cross cut sled and I can push my material through here and run it through that way. But again, I'll always support the longest side. That's the most important thing. After that, the other issue we occasionally see at the beginning of the semester, our students try to freehand cut, either using, when I say freehand, I also mean using these push sticks. They will try to hold the material and just run it straight across. You always use a fence of some type, either the rip cut fence or the cross cut fence or a miter gauge. So the next most dangerous thing I often see on the table saw are students reaching to grab a small piece after they've made a cut. So say I have a small piece like this, after it passes through and I make the cut, so in this case, when I finish the cut, my stock would end up here and the offcut would be right there. I often see students go to grab a small piece of material like this. That's probably the most dangerous thing you can do in the lab. So never try to reach and grab anything from near the saw. If you want to move it, you can use your push stick and just push it out of the way, or you can just wait till the saw spins down. Either of those are very safe. Never attempt to grab a piece of material near the blade. The blade is spinning incredibly fast. If it catches the material, which it can do if you put pressure on this side, and then when it yanks it away, your hand will kind of move in where you were trying to grab the part, and you can touch the blade. So always make sure to use the push stick or just leave the stock in place. So after part orientation, holding the part on the longest side, and then putting your fingers near the blade, the next bit of issues all usually pertain to causing kickback. Poor operator error causes kickback. One of the most common is when you finish a cut, students will leave the stock next to the blade as soon as the cut finishes. So as I'm pushing this piece of material through, at this point right here, the part will be finished cutting. So the blade is taller than the back edge of the part, so the material is completely cut, and you'll feel that resistance, and people will turn the machine off and let it be. But you really want to push this piece of stock completely past the end of the blade here. So now the stock is completely forward. That's the safe position. Another cause of kickback, as you're making the cut, this left hand, you want to make sure you're not binding against the blade the entire time you push through. So when I initiate the cut, I can press the stock firmly together. But you can see here, as I get going, at some point, I'm going to be pushing the piece of material against the blade. So it's no longer attached to this piece, and it's going to be right here. A lot of students will keep applying pressure, and then this will bind up against the tooth and get thrown back, causing kickback. When making a cut on the table saw, the primary push stick goes in the center between the blade and the fence, so make sure you're not putting it towards the fence. That leads to an unsafe situation where the part can start to twist and be thrown backwards. If you think about it, the blade is putting pressure this way, and then if you have the push stick on the opposite side, that works to rotate the part. When the part starts to rotate, it's going to get bound up and cause kickback. This is getting a little bit into the operation of the table saw, but when you do push through, you want to make sure that you keep your wrist straight and push straight down and keep it firmly pressed over, and then go through in a straight motion. If you start twisting your wrist in an arc-like pattern, then you'll have a poor cut quality on the back. Whenever you're using the table saw, you always want to make sure there is a riving knife at least. A full guard is preferred. You can also use a fixture, but when you're using a fixture, in most cases, you can leave the riving knife installed. The riving knife is one of the most effective safety tools we have against preventing kickback. So make sure the riving knife is properly installed. Even when you're using tooling, in almost every case, you can leave the riving knife on there, and the part will actually pass right by there. So you do not need to take it off in most cases when you're using tooling. So the riving knife should almost always be on the machine. Again, it's one of the most helpful tools to prevent kickback.